Okay, something about there. Okay, so here we go. And we're going to switch over to our bordered view. So, if you haven't been watching or want to catch up, there's basically, we're picking up again uh, with development on Bike Race again. So, still working on the trail spawner. In true developer fashion, I got completely distracted by developing some other piece before I finished the actual item spawning. And that piece was a clock. So we'll go over the clock today, and then we'll also go over the, um, or we'll keep working on the trail system, which should be mostly set up at this point. So again, you see this trail of stuff here. So this rendered line, we're going to work on rendering and spawning some items inside, or along this set of trails rather. So we'll look at that. Get really far, maybe we'll just work on doing some simple, like, visual effects, do some volumetric particle effects, which would be kind of cool, so that we can add those to our speed increase as we keep going, or our dash mode, or acceleration level, or what have you. So, looks like this got a little bit loud, so we'll pull this back down. Okay, that should be good. And then we'll look at this and we'll continue with that. So, I did pull the GitHub. I haven't gotten it quite in the video description, but this will go on channel descriptions, and I'll try and remember to put it in the end of every video, or in descriptions or what have you. So, most of the changes you see here that aren't like Bike Race game specific are going to be available through the Bug-Free Productions library on github.com. So you can go to github.com/myusername, Isaac Busted, all lowercase, /Bug-Free Productions library. And this is going to be the core of my XR, AR, VR, 3D, 2D library. So all of Unity library separated into different types of namespaces. Most everything is going to be in the 3D. Most everything's going to be in the 3D library, but some of it will be separated into different namespaces. So you can use this for your future projects, which should speed up a few things. It has instantiation factories, it has scriptable objects that you can create and use, and what have you. So one last time before we move in, welcome to Bug-Free Productions. Here we try and make productions that are bug-free, or at least as much as possible. I am your bug today on the rug, Isaac Busted, and we'll be pulling in to Bike Race. One thing I wanted to mention, apparently they changed how this works. So if you double click this, it'll open up just the class. But if you right click and go open C# project, we can actually open the SLN, which will open it to where we were last time. I suppose this was also there in the last version of Unity, so it's not a new addition, but it is. It used to run open. To open that, it used to run open C# project, I think, so it would open to where you last were, but now it doesn't open the SLN, it just opens the file in the editor, even though it does open the file structure, which, okay, but, so whenever you're resuming session on a machine, open C# project, and that'll bring me back to everything I need, or at least I had open before. So you can see clock manager, clock notification, clock SCO, and iSubscriber, subscribing factory item. This does bring me back to maybe it would be good to cover two different things here today. I have to Come on. Oh, it's that reason. Okay, so Clock Manager is the manager I made to just run things on the time scale part of it. So one thing that's kind of touchy about Unity is it works really good for small amount of objects, but as you build a bigger game, and this kind of goes for every engine, running every game object having a run on every frame gets very bloated. We get around this a little bit with update. So update, although it updates more often, updates less often than, or has less running on it than a fixed update, where physics is calculated. So typically, by default, you have 50 frames a second per physics frame, and you have 200 frames per second of update frame. Update is variable, where fixed update is fixed. So that exact number of 200 frames per second varies a lot between different computers, but essentially we don't know how often it'll run, so that's why we get our fixed time.delta time. So in update we run clocks and we get fixed time.delta time. And then quick overview of the clock notification before we start running down the whole thing. Well, we'll skip that for right now. But then I also set up an SCO in here. So we have, and basically this guy connects to manager, and he gets a whole setup on that. So our manager, or our SCO, is basically our items subscribed to our clock, and then this clock, when called to run, updates itself, updates on a time step, and this will be edited a little bit better for timing, but this is the general idea. So we get index out of bounds, reset, current index greater than equals subscriber.count. So according to our subscriber count, we're moving through we don't want to leave the bounds of that array, or it might be a list. Usually I use lists. Yep, so it's a list, so we don't want to use anything outside the bounds of that. So we always reset it to 0 if we're outside of the bounds. Because count is already outside the bounds, we can set it equal or greater than, since it's an integer, without having to do the pesky -1, which is not very legible, to be honest. Time elapsed, so we have time elapsed by the interval, and this is just to stagger out across frames, so we're not calculating every single frame, but we still have the option to calculate in time step. iSubscriber updates we'll actually talk about before I go back to the clock and cover a full rundown of it. But subscriber, the only thing I really did here is I added the onsubscribe with an iSubscription, and I did this because I needed more base class flexibility, and also it didn't really seem to make a lot of sense to force this method into inheritance. It made more sense to just I need to go to iSubscriber to show that. It made more sense to just let other classes inherit into it and not, or inherit it in. Let's take that one more time. It made more sense to implement the interface in another class, like the ending class, than it made to inherit a custom class that forced me into inheritance. There we go. So as we keep going with that, that's just kind of the idea there. I'm gonna flip to full screen now, and we should still be good. Yep. Okay, so that's the only change to that class. With that, I think I'm actually going to go over and start I should probably get something for like title cards so I could just scan until the like visual flip. And also use that for the thing. Maybe that's something we'll have to set up in Affinity. Set up something. That sounds like something fun to do for this week. Yeah, let's do that. Set up title cards in Affinity. And if anyone's wondering why the video went up and the or the VOD transferred and there still isn't any new stuff, that shortened video that I was gonna mention, it's I got distracted with subtitles. So setting up subtitles for both the stream, which should nope. Which should be available now. Yep. I got distracted with that and also with getting that for YouTube. So there's a new, or I don't know how new it is, subtitle edit application that can automatically do your subtitles, or at least your first pass, depending on how serious you are about your subtitles. As a one-man setup, I am on the quick edit side of it, so I don't, I kind of just run it through and hope for the best. Look through it, make sure it's not terrible, and then move on. But you can definitely use it to also edit and make things a little nicer. So hopefully that'll make nice subtitles for when the friends join in. So set up title cards in Affinity for patterns. Actually, this should be for pattern videos. And I didn't save a location, so instead of it being in the file explorer, we're just gonna leave that there. Alright. And I used to really worry about my path showing up on videos, but at the same time, it's like you already have to be in the machine, at which point you just clone the drive and filter it later, so, you know. Set up title cards in Affinity for pattern videos. And also after seeing some of the programming machines, like the different developer machines, and everybody just has crap on their desktop that's like 500 files just sitting on the desktop, I'm not going to feel bad about anything that might show up by accident. The only thing I'm trying to do is, I mean, this doesn't really help anything either. It's like not showing the system clock. Probably doesn't add a whole lot to a video with a timestamp with the time of day and the date, but yep. So at any rate, we continue. And we're going to go ahead and start at the beginning, I think. And the beginning is going to be, what do we want it to be? Patterns. So this one's going to be singleton. So I don't really use I do use Gemini a little bit for like researching some stuff and patterns, and a little, or not implementing patterns, but researching like some of the documentation for Unity type stuff is like scattered all across forums, so it's a little hard to index sometimes. I know I looked into the I looked in Unity documentation several times, and sometimes it was empty for things like when netcode for game objects first came out, and I looked into a couple other things, and sometimes it's not quite right, but That's all the bigger I can make that. That is sad. I can't adjust that. Okay. Any rate, the singleton. So the singleton's what we're going to start off with first today. And that's going to be the base. Like, it was kind of an afterthought for the clock, but it's going to be the base of what keeps our clock, our single clock. So, all right, let's get started with the singleton. So with the singleton, I'll just go back to my VS Code, and I'll scroll all the way to my singleton, or maybe I'll go to my clock, and we'll go to the singleton. So you'll notice in where I used it, the clock manager, singleton has the type passed in of clock manager. So this clock manager, while inheriting from singleton class, is passing in itself as a type. And we'll see why that's important in a second. So this type of singleton is one that I found on Gemini up until just surfing the forums. I didn't find one quite like this, so I don't know where this one came from exactly. There wasn't like a citation on that, even though Gemini is trying to do citations for different information. At least trying, maybe. But so I'm not sure where this exact one comes from. Usually when I see the type, it's still a singleton. So like this instance is not a singleton, or is a singleton class. It's not the type that gets passed in. So this is kind of new to me and kind of interesting. Just being able to do it this way. And I don't use generics a whole lot, just because a lot of times they end up using a lot of extra effort to make work. That's why my factory item and my pooling system is all just kind of inheritance based, because I just didn't really want to deal with generics. But it's perfectly fine to use generics, and what we mean by generic is this type could be any type. It's just a generic type that gets passed in and is treated as that same type, and we don't really have to worry about what type it is, because we simply are not worried. So at this point, we're just going to tear down how this looks. So this singleton is a mono behavior. So we need to pass in a type of mono behavior, and it is also a mono behavior. So easy way to read this line: public abstract, so we cannot create it. So we're creating an abstract class. It's not what we wanted. There we go. So this is an abstract class. That we cannot instantiate. And what's good about this is it forces us to not use a singleton class as is, but rather the type that we pass into it. Which is kind of important, because like I was talking about like a couple seconds ago, if this instance was a singleton type, we would then only be able to have one singleton total, instead of like an audio singleton, a game singleton, so on. So we have an abstract singleton type that we cannot instantiate. We have the type, so we pass in the type we want. And this particular class makes that type into a singleton. So pass in type we want to make single. and we are declaring that this singleton will be a mono behavior. So that's just a Unity thing. It inherits mono behavior, meaning we can place it on a game object as a component. And then where type t, so where t is also a mono behavior. So we can only pass in mono behaviors at this point. Which means that, which is important in singleton, because if we were doing this as a standard C# singleton versus a mono behavior singleton, we would handle them entirely differently. Which we'll see when we get down to instance. So private static t instance, this instance is of the type we pass in, which is very important. And then application is quitting. This is a editor / Unity check type thing. This is specifically retaining to handling when application runs.quit. But the most important part is persistent. So this is just another thing that we use to set it up. So if it is persistent, we want it to not be destroyed on scene cleanup. So we make it persistent. Which yes, they did implement. This one hasn't been fully implemented or validated yet, so you're kind of seeing it a little bit live. So then we have public static t. So we have the t instance. So this is how we access our private instance here. It's worth noting that you'll usually see me use protected instead of private. Well, that's not entirely important here because we just don't really inherit this thing in the traditional sense. Like, we're not going to be using this instance from something else, you know? So if application is quitting, run null. So just don't do anything on application quit. Instance equals null. So if the instance is null, we want to create an instance, right? So we try and find first object of type. So if we can find it, then we check if it's equal null. We want to create one. So if we don't find anything, we want to create one. Singleton game object, instance singleton object. Finding first object. So this is assuming that our designers and developers do this well and only ever place one of these in the scene, which may or may not work, but we'll get to that in a minute. So it might be beneficial to like try and check if we are this instance as well. So once this part might get replaced is what I'm saying. But if it is null, then we do want to run this. And then protected void on awake. If instance equal null, instance this t. So we're casting the instance we have into a type of t. So this singleton basically will be treated as the type that's passed into it. And if persistent, do not destroy on load game object. So if we marked it persistent, it will add itself to don't destroy on load, and it will continue between scenes. Else if the instance is not this. Okay, so here's our check. If instance is not equal this, then we destroy the game object. So on awake, okay, so here's our check. And then that works. So we check in our awake, and if we have an instance that does exist that is not equal to this object, we destroy. And if it's null, then we add ourself to it. And then we protect, void on application quit. So this method runs on application quit. Set that to true. So this is just to handle our application quitting. Sometimes there's some memory stuff that we need to clean up. So this is a good thing to have for this type of object. And then we have on destroy. So protect a virtual void on destroy. If instance equal this, instance equal null. So when we destroy the object, we clear our instance variable as well. So that's kind of nice. This was said to allow for multiple objects to inherit it, or not inherit. Said to allow multiple objects to be made a singleton using this class. So we'll see how true that is later. But for right now, this looks pretty good. It sets up, it runs. So far it runs as advertised. So we're going to continue this one and see if we need to change that later. After reading through it like this does look pretty good. And the reason we have to do this is because we are looking to make sure in our clock script that our clock manager only ever has one object. Because if we have multiple clock managers calling singular clocks and updating them twice per frame, it's going to mess up our timing. So we need to make sure there's one clock manager calling the multiple clocks to keep everybody on time and in sync. So that's pretty much the singleton pattern. If you have additional questions or want to see an additional example, feel free to drop it in the comments or in the chat, and we'll move on to the next set. We'll also revisit this later after I do some testing and maybe some re-implementation of it in older classes, and we'll see how it goes from there. So till then. Okay. The next thing is not singleton. The next thing is clocks. So we're going to drop and get some water. And this is going to be a little bit different than the other clock. I'm going to let my voice come back a little bit, maybe. Okay. Whew. So clocks are going to have clock manager. Maybe we'll make a little bit of a clock manager, and then we'll have a clock and then we're going to need our, what is it? Trail item. So there is a thing that I didn't set up yet. And although we have a clock and we have a setup, oh, actually it's not important for this right now because our clock is going to connect to this and that's all we need to have right now. The scaler is the other thing. So the item scaler is going to get separated into a separate class. And the reason it's going to have to get separated into a separate class is because we're going to have different things running on it. So it might be bounding between two sizes. It might be growing linear from large to small, or from small to large, and shrinking from large to small. And it might be doing those two things. So we're just gonna, or those three things, any one of those three things. So that's probably gonna get separated out into a separate object. But it's not important for our clocks right now. So I filled up like almost a whole gallon of water to sit here next to me. Okay. But we're sitting at this right now and we're perfectly fine. Gonna pull my adjust position a little bit. But yeah, so that's basically the thing. Not too bad. Not too bad at all. And we're gonna be looking at some edit type stuff. So let's look at the clocks now. So let's pull our note back up. Clocks, clock manager, and clock. Let's take a drink of water until we can say that. Clock manager, clock. All right. So let's go back to our clock. So picking up better clock manager. All right. So now we're going to cover our clock system. So clock system consists of a single manager that exists in the scene using the singleton. We covered that just a few minutes ago in a different clip. So feel free to watch that when that goes up on YouTube, and drop some questions in the comments if you have any. But for clocks, we're going to move on to clock manager and clock. So what do we do with this? So this clock manager being a singleton, there's only ever one of them. We use that to make sure that we are updating our time correctly. And the whole idea behind the clock manager and the clock is to ensure that we do not ever have a bunch of different objects all updating the timings of our different objects. Because we never want that to happen. We always want complete control and smoothness out of that. So let's look at it a little bit. How do we achieve that? So we're going to use a public or a protected list of our clocks. So this is where our clocks will be stored. And I think I was going to implement a subscriber pattern at one point, observer pattern at some point, but that kind of fell out of favor due to I just didn't really want to do. It seemed a bit like beating the dead horse because there was no point for them to call to subscribe. It was entirely dependent on, like, it's pretty much going to be dependent on us assigning them because they are scriptable objects. They can't exactly go into the scene and grab whoever's there. And also, they're not going to exist in every scene or be needed, so I'm just going to allow my clock manager to hold a reference for a prefab. So that's kind of my idea on that one. It's kind of developer's preference at that point. But we also have protected override void awake. So created in awake. Base is just kind of added. I'm not sure what all entails in base. For each clock in clocks. So every developer's favorite thing. 3 words that look almost identical in a row. Yes, check. And then we run each clock's setup. So every SCO, we run setup in our awake. And we do this because when the object is created, this runs. As long as the top level object is active, which it will be because this is not a UI that turns that we have to have things turned off to turn on enable and stuff like that, so should be safe. At least until we network it, and then all safety is gone. Awesome. So then we have protected virtual void update, so just using the Unity method to update run clocks, and run clocks is actually based on completely self-contained. It is basically going to step through all of our clocks and tell them that time has passed, and it's going to tell them how much time has passed. Very simple script on the manager part. All of our actual difficult code is in the singleton, so feel free to go back and watch that once that goes up. Or watch the video here on Twitch. So we're going to go ahead and jump to the next thing. So what's after our clock manager? Well, if we follow the flow of time, like directly, we run to our run clock method. So jumping to run clock, here we go. We have running clocks, and we have setup. But before setup, we even have a scriptable object. So you'll notice the same boilerplate, create asset menu. I don't highlight too far to the right because it tends to jump around in Codium, so based on where your cursor ends. And then we have initialize on load. This is actually a holdover. I'm going to delete that. I didn't like it. So the thing I didn't like about it is that that's like a Unity editor thing. And that's only available in the editor. So if we set up our code to run like it's only in the editor, unless we're running something that is supposed to be in the editor, it's entirely defeating the purpose of programming it in the first place, at least in my opinion, because I don't have time to go back and recode things. So I just kind of code everything to run as if it's going to be compiled. Which maybe you have a test case or a use case that is useful, but for my general use, it is not. But we see scriptable objects, and we see iSubscription. So go back and check out the observer pattern video, or either the VOD or the clip, and check that out. But then we have a clock. So what does this mean for the clock? It means I want things to be able to subscribe to the clock. It's going to work slightly different than it has on other classes I've used the subscription interface on. So iSubscription is going to allow the item essentially to hold a reference that it can subscribe to. So they'll hold a clock SCO item actually, and then call methods implemented from iSubscription to implement the observer pattern. So let's go ahead and look at our vars region. So our variable region is protected float time interval. So this is the idea of how far apart we run our intervals. The time elapsed, so how much time has currently passed since the last interval change. And then protected list iSubscribe. So iSubscribers equals new list. So we're just holding a reference of how many subscribers we have and who they are. And the reason this is a list instead of on a delegate like we had in the last one is because it is going to be more convenient for looping and also indexing. Because if we had it on a delegate, we would just run all of them. But part of the thing with the time skip, or time step, not an anime, not a time skip. Part of the problem with the time step is that we're not going to be able to run through all of them in a single frame all the time. So we want the opportunity to control how many of our subscribers are actually called and what values they get. We don't want to just send everyone, say, a 5 or a 4. We want to give them different values depending on what our actual goal is. So yeah, this clock is not like an end class, it's a working point that will work currently, and then we can possibly expand upon later because we're still in like the rough outlining set. We're not necessarily certain that we can stop and do that, or that we can stop with just this class. So, in the current index, very straightforward. We're just holding where we are in the list presently. So, iSubscriber notification, sub message. So this is our subscriber notification that we need to pass into notify methods in order to properly communicate with different subscribers. And then we have the end region vars. So this ends our variables and we enter our methods area. Quick water shot. So as we move into the methods, or into the madness, we have virtual void setup. So we have a sub message equal to a new clock notification. So this is done because we can't really construct a struct based on our time interval in the beginning of the class. So if we did that here in our variable section, this would actually cause an error because time interval doesn't exist until after the instantiation of this object. So we need inside a method to do that. I'm going to do a quick Control F for on enable. And I notice how it's not here. So setup needs to run on enable probably. So let's do a protected virtual void on enable parentheses enter brackets enter. And we're just going to run setup. And this is just going to tell it that when we set up, we're going to, once we set up, we're going to be fine. And we're just going to get the sub message and construct a clock notification so that our clock can update our subscribers. And then we have public virtual void check time step. So our time step is our time interval. And you'll notice it's capitalized. So let's actually go down to the accessors before we continue the time step. So for our accessor, what I've done so far, and this math is subject to change currently, subscriber count. So I want time interval to represent not the interval of time we're expecting. I want it to represent, okay, let's try a different way. Time interval lowercase represents the amount of time I want to update all subscribers in a list. So I want to have capital time interval be an accessor that I can find the actual interval to update a single subscriber. And I want if subscriber.count. So if the count is greater than 0, I actually do what's in here, which is return time interval divided by subscriber count. So this is not actually like this is a mathematical condition where I can't divide by 0. So that's why this if statement isn't here. Otherwise, we could simply have time interval divided by 0, and else we just return 0. So this should be fine, and time interval should never be 0, because if you did that, you already... Nobody has a time interval of 0. That would be an infinite loop, and it's already broken. So, which we could add an if statement in here for... Maybe we should. And... Which is... That's not it. It's kind of hard to... There it is. I don't... Despite using it a lot, I never remember that it's under 7. So this would be... time interval. Because you can't have a negative time interval as well. So as long as it's greater than 0. So as long as these two things are true, we can return this. Okay. So with that making sense, let's look at time step. Well, time step does execution, so let's first look for when it's called. So this time step is called when the clock is run. So you'll notice that in our clock manager, we call run clock on update and pass in the float time. So when we run this clock, we pull in and add to time elapsed, the a delta time, and then we check time step. So check time step is meant to be our action here. So what's our action do? We check time interval, and if time interval is greater than 0, while the time elapsed is greater than or equal to the time interval, we current index is greater than equal to subscriber.count. So, okay. So while time elapsed is greater than or equal to time interval, we loop through this. And this loop is meant to make sure that we stay within the bounds of the list. So setting our index to 0 if we exceed it, exceed the available indexes, and decrement the time elapsed. So this is our exit condition, meaning that time elapsed minus time interval eventually leads to exiting this loop. And I'm gonna flip that out with that, just to make sure we're keeping on the same time. So theoretically, this probably still results in all 4 of these running. Well, all 4 of them should still run in the full interval, but if we start, like, say we add 0.5 and we only add on, or we only run a single instance on 1, then every 2 frames will run 1. So it will limit that way. It's a little less, yeah, so it helps distribute our frames a little bit. And this is what here distributes it. So subscribers current index, so that current index we're tracking. And then we're calling to notify the sub message. So on notify, we're calling on the subscriber, and we're passing in sub message, which is our clock message. And then we increment to make sure we move on to the next instance. That's why the if statement is here and not at the end, because then we can cleanly increment every time and also make sure we aren't outside the list before we begin. So moving on to subscribe and unsubscribe. So basically, when a user subscribes to this, we add subscriber to our list. And when we unsubscribe a user, we remove them. We should probably also call, and this is something I added a day or two ago, I think. Subscriber dot on unsubscribe. And the reason I did that is just so that it can, there's certain things they do when they unsubscribe that they might want to also call. Where this is a little less like that, because usually the subscriber calls this. So they pass themselves in to subscribe. It's not done by something else, although it could be. That's just kind of the way it is right now. The notify, so we don't quite run the notify in the normal way because our check time step does that. So run clock to check time step runs all this logic. We don't necessarily need to use the notify, but we do need to implement it because we implement subscription. And then we hit the accessors, so we've made a full loop through the code. So what does this look like for an item? What it looks like for an item is, I need a trail item. Trail item right here. So what does this look like for a trail item? It looks like a subscription to a clock. So we have protected clock SEO clock. And in that, we have in our, ignore that. Doesn't look like we implemented that. So we'll go ahead and protected override. Let's go ahead and change this. So subscribing factory item. Right. So instead of doing this directly into the item, I actually did this into a subscribing item. We can do more on that after this section, but basically this guy handles the subscribing factory items. So any factory item that needs to subscribe to something can use this inherited class. And using this inherited class lets us do something like have specific item methods that can be overridden. So instead of implementing the class every time, which would cause us to run into hiding problems, the idea is that the base class is implementing it, and the way the base class is built puts into that implementation things that we can directly override. So creating that kind of flexibility and structure of the structure of an object, but the flexibility of an interface a little bit. And this is just because I anticipate a lot of items needing to subscribe soon, for reasons I'm not quite ready to describe, but essentially I'm implementing iSubscriber. You can check out one of the earlier videos for that. But it's in the observer videos. So we have factory item. Not much you need to know about factory item. So we have a protected list of iSubscription. So normally I don't keep a list of subscriptions. But in this case, I did want a list of subscriptions because subscribing factory items might subscribe to multiple things. And while the subscription handles notifying the subscriber, it might just be useful if it ever needs to unsubscribe. So this is like a just in case. So then we have on notify. So implement subscriber section is just implementing that. And inside every implementation, I have an item notify, a sub message, or item unsubscribe, which just calls these protected virtual methods out here. A subscription.subscribe this. So if I am asked to subscribe to something, I pass in this to the subscription. So I pass in myself to the subscription, and I add the subscription to my list. The other reason is, now that I'm an object, I might want to unsubscribe. So if I need to, factory items can get destroyed and can get, they're objects, so they get cleaned up on collection. So this is a quick way to allow me to unsubscribe from things. So for each subscription, when I want to remove everything, I unsubscribe this and I remove subscription. Which actually means that, what was it? The item trail, why is it not, because I scrolled through. Clock SEO. Maybe this is not a good idea, because I'm already kind of using that for something else. So maybe just removing it is fine, because as long as I remove it from here, I'm not looking for it. Or I'm not getting notified. Whereas this unsubscribe is just to remove it from all of them. So it looks at all the objects that it ever did subscribe to, asks to unsubscribe, and then cans itself. And that's how a subscribing factory item kind of works logically. I didn't really implement a regular unsubscribe in the base class, and that's just because I don't have any use case for that yet. The whole idea behind a subscribing factory item is that somebody else spawns it. So it's not going to be able to necessarily always get an end-all subscription from the scene. And on item notify, a subscribing object doesn't necessarily have a default pattern, but we do need this described in order to complete this type of implementation. Yeah, and that's pretty much the clock system so far. So we're going to use this new iSubscriber. So this new subscribing factory item helps us manage that. And then the trail item is going to implement using the clock. So let's go to the on enable on setup, and let's actually implement the clock specific one. And actually, I'm just going to comment this out. I was playing around with using this to help with item scaling, but I don't see that it's going to be helpful. So let's go ahead and define setup to if clock SEO. We need lowercase clock is what we need. If clock is equal to is not equal to null, then we are going to subscribe. So we are going to follow this again and just double check what our subscription, what our item subscription is. And that's the other thing, our subscription is actually handle, or this one we handle here, but we need to subscribe. So our subscription works in, I can just call the subscribe to the item, which is probably the easiest way. So I need an item subscribe as well. So let's do that. Item subscribe. And this is going to be override RRIDE. I spelled something wrong. Item. I also noticed I didn't start the bug for this one. And that's kind of why I don't hand set up my certain stuff. I think I'm gonna need to use autocomplete to get this to work. Just because I do not remember. Otherwise I have to go copy it, which also works. Item unsubscribe. Clock. Dot subscribe. This. So then we can use that one. And clock is going to use in setup. Item unsubscribe, parentheses, line. Which we could just call clock.subscribe, which would be more straightforward here as well. There we go. I'm going to check subscribing factory item, just make sure there's no on enable, awake, or any other Unity type methods, which it looks like we're clear on. So this guy should all be ready for testing. So this is going to enter testing with this general layout, and we'll come back with how that works. So what can we do here? We got clock manager. Okay. So there's nothing really left for this one, so we're just gonna do some general development for a little bit. About the next 20 minutes, probably. Um, just gonna do that. So, what do we want to work on? Means that last video is gonna be about 40 minutes long. Oof. Long. It's gonna be a long video. So what we got? I subscribe, bunch of stuff. Let's look at the Unity. Okay. Okay, so what can we do here? We're gonna do some subscribers, some subscription. Maybe we stay with the notepad for a minute, and let's just think of some ideas. So I have the item spawner. I have the item factory, I have the subscribing. Maybe we just set that up. Item spawner. Maybe we have like a test spawner that just spawns every so often on the clock. That should be good. Yeah. Let's try that. So let's open that up, open that up, open that up. Nope. And we'll pop to the whole body. Did I not save that? No, it's under this. Right, because position reasons. Color palette. It's locked. Turbulence and wake lines. Okay, so our turbulence and wake lines, one left, one right, one up. Lines 1, 2, and 3. Point delay, time to last point, line drift, trail offset, V offset. So, we're gonna go ahead and add a spawner. Did I delete that? It's probably just under trail item spawner. And I'm gonna edit this script. What is my script? If multiple orientation trail system, a trail system, trail system, trail system, trail system, subscribe. Setup. Okay, so we have that it wants to subscribe to a multiple trail orientation system. And unsubscribe, unsubscribe. This is the implementation of the iSubscriber. Then we implement the subscription, being that our subscriber item should subscribe to us and do stuff. So subscribe should do. I don't think there's any reason to keep a list of them because this is one of them that just pushes out information. So whereas the clock was implemented to like do scaling over time and keep those guys running and offset how often that runs, the on enable is not meant to do that, or that. This is meant more to like check if we should spawn an item, and also let them update based on our position, I think. So everybody gets this update. Everybody on the trail system gets this update. So what does that look like? That looks like having a reference, subscribing. I think everybody can just receive the same notification every time, which brings us back to our delegate ideas. Delegate. So we're going to have a protected action. What type of action? It's going to pass a I subscriber notification. And we're just going to name what this is. So what's the action? I'm just going to call it on. So this is going to be on. I can't think of anything except on notify. Let's do, I don't know. We're just gonna call it broadcast data. I can't think of anything. Broadcast data line. And then I guess we're just gonna be equally stupid and protected data, which it's gonna be broadcast data. And then in the vars on enable, setup. So this setup stays the same. We do need to add a, let's move this outside of the Unity methods area. We're going to do protected virtual void. On. Nope, this is just update. And we could probably make this guy look to a clock as well to see how often he should run update, but let's worry about that later. What we need to worry about now is getting our logic to run. The other stuff is nice for the moment, but we need to make this run. So we're going to just invoke trail, no, not trail item factory. I didn't put cast in there. Broadcast data. Invoke data. And then Setup does need one line added, and it's to construct this. And what data do we need? We need the time, right? So maybe let's create a new header here. So we have subscribing tail item, time to last item. So we need to know the time since last item, correct? So the time last item was placed. We need to know the distance. Space between items. So I'm actually going to move that here. So item placement parameters maybe. Item placement parameters. And with the item placement parameters, what are we going to do? We're going to go ahead and also add a field that says space between items. Serialize. Serialized field. Protected. Float. Distance between idea being that so this would be 1 unit apart, probably not a good distance. Time to last item, this shouldn't be serialized at all. Because time to last should just be updated by the code, shouldn't be done anything with. I think I'm looking for time between items. So it would be time between items somewhere. See what I mean by jumping around? I don't. Actually, I can close you. There you go. Now we can do this. So time between items. And with the time between items, we might be spacing out a little bit. It's almost the 1.5 hour mark, so we might just be wearing down. Okay. Virtual on enable. This is about the time where it's like I would probably be looking and answering questions for anyone posting in chat. And you can join now at about, what is it, 10? I'm going to be starting to do these at 10 a.m. so that I'm just a more convenient time for me to get it to do these. And we got subscribe, leaves me open to like travel during the weekends and stuff, which I still need to do from time to time. So we're gonna be doing that for right now. On enable. So 2 things. If we have a set distance, like minimum distance between items, do we need a time? Do we need a time? is the thing. We kinda do. And actually, I'm noticing that this might not be quite good. So I'm thinking ahead for management right now. And list is probably going to be a better mode of doing this. And we'll destroy that and we'll run notify instead. And we'll edit that in a minute. So the reason I'm thinking list is that the protected list is going to allow us to reference the last item in the list, which is going to be the last item we added. So if we add no, also still no. Q. QU EUE. We're going to use a Q. And the reason we're going to use a Q is because it's FIFO. So this is going to be subscription management. That's just what we're going to change this one to. Why do I want FIFO? So this is going to be my subscribers. Subscribers. Subscriber. I like using queues when I know that I need a FIFO solution. So as soon as I know that the first one in needs to be the first one out, I like to do a queue instead of a list. Just helps me manage it because the idea behind a queue fits that better. So instead of managing a list, I'm just going to manage a queue so I can use NQ and DQ and stay completely in sync. But I can also still cycle through the whole queue. So I think I can still just loop through with a for each without dequeuing. And it's going to be for each subscriber. Sub in subscribers. Then we're going to sub dot notify. I deleted data, didn't I? Yep. So let's go fix that too. Protected. I subscriber notification. Notification. And that's null because I'm not, or just empty because I'm not sure what I'm doing there yet. Notification. Line end. Okay. Adjust the leg. Okay. New a subscription. So trail item, deploy to item spawn, item data. So this is delaying the item spawn, taking in orientation data. So we have already set up a way for okay, so this is for the trail renderer to talk to this trail spawner. And the trail spawner only needs the orientation data. It doesn't actually need to subscribe to anything. We could implement the subscription part, but that's just kind of building in extra connections at this point. I think I was planning on subscribing to it. But it wasn't set on the setup of it. Because let's look at orientation data. It's a spawn item. On notify. So I think I am planning on doing that. So I'm planning on having it subscribe to the trail so I can receive updates. Which should be fine. Yes. Anyway, there's gonna be a lot of pushing and pulling on this one, so I'm probably gonna end it here, and then, yeah. So, if you're ever interested in catching him on live, we'll be doing this at 10 a.m. Tuesday, Thursday. Tuesday code, and Thursday doing art stuff, so we'll probably be doing title card stuff, actually. So it's probably setting up some title cards that are easy to change in Affinity for the different videos and stuff that I'm going to post. There might not be any bugs currently on screen or in the next videos, so unfortunate, but we should still have different bars and stuff for that. So, till then, hope you guys have a bug-free day, and we'll see you later. Check out the Twitch. Check out the Twitch at BFP, and check out the Twitch at Jib at BFP, and the YouTube at Bug-Free Productions. In case you miss anything, don't forget to follow and subscribe. Have a bug-free day.